So in this chapter, we want to look at the elements and compounds. The reason elements are important to us is because every single compound material that you see around you is made of element, two or more, and sometimes even one. So in order to be able to understand the properties of different materials that we have, in order to be able to discover, explore, and invent, we need to understand the elements, their properties, and once we understand the properties of the elements by themselves, then we can look at the combination of the elements, interaction between them, and how different compounds and molecules are formed. So we're going to look at the elements. All the elements that are known to us are listed in the periodic table. We're going to look at the periodic table, the elements, some general properties of the elements, and then based on the general properties, next step is looking at their atomic structure. And once we learn the atomic structure, we will be at a point that we can actually decide what elements, to combine with each other to make a material, a compound that has a specific properties. So in order to be able to target, synthesize, and make new materials with the properties that we're after, we have to understand the elements that first of all exist and then their properties. So we're going to start by looking at the elements, their general properties. Also, we're going to be looking at periodic table. Everything we need almost is found in the periodic table. So I'll show you how we read the periodic table and what information we can get from the periodic table. Now, obviously, you're not required to memorize the periodic table. Periodic table will be given to you. But as we cover the material, I tell you what you are required to memorize. So the entire periodic table, there's no need to memorize that. However, you should be able to get information that you need from the periodic table. So we're going to start the chapter by distribution of elements, what elements we have in the periodic table, their names, and also the symbols. And then from there, we're going to look at some compounds. So element is a fundamental substance that cannot be broken by any chemical means into anything simpler, and the elements are basically the building blocks of matter. So some elements exist naturally, but there are elements that we can actually synthesize them. The reason we can synthesize them is because we know exactly what the structure they should have, how many subatomic particles, and what type of subatomic particles, so they can be synthesized. Now, elements are composed of atoms. Atoms are the smallest particle of an element, and atoms cannot be broken into anything smaller. So since atoms are the fundamental particle or part of the element, it's very important for us to understand and study the structure of the atom. And we're going to cover some subatomic particles. Those are the particles that atoms consist of. We're going to look at their names, their properties, and how many of those subatomic particles each atom have. And based on the subatomic particles, we're going to look at the interaction of different elements. Now, currently there are 118 elements that are known. Out of that 118, 88 of those elements are naturally occurring. The rest of them are man-made. So a couple of facts about elements. Two elements that are found liquid at room temperature are bromine and also mercury. And there are some elements in the periodic table that they are found naturally in a gaseous state. Those are hydrogen, oxygen, nitrogen, chlorine, bromine also in a gaseous state, and inert gases, which are helium, neon, argon, krypton, xenon, and radon. So we'll talk about these elements and their properties more throughout the chapter. So this table shows you the abundance of different elements on Earth. So oxygen is the most abundant element on Earth, 49.2%, and after that, silicon is the most abundant. And then obviously on Earth, we find all sort of trace of different types of, metals and different types of elements. Now, oxygen is obviously makes up the most of the atmosphere, 20% of the atmosphere, and basically we can find oxygen everywhere. Now, just to give you an idea of how the elements, the percentage of elements in a human body, as you see, we have trace of different metals and different elements in our body, but again, oxygen is the most abundant in our body. Oxygen is about 65% of the human body, and carbon and hydrogen are the second and third most abundant elements in human body. Now let's focus on these elements and their properties, and then we can talk about the type of compounds they make, and then we look at more at the chemistry of these elements. So the name of most of these elements in the periodic table are derived from their properties, and most of them, they have Latin names. So if you come across elements where their name doesn't match their symbol, just keep in mind that the symbol is based on the Latin name for the element, and it may not actually match the name that we know the elements by. For example, iodine on the periodic table, the symbol for iodine is I, and the reason we call that iodine is because it has a purple color, and in Greek, the name iodus represents the iodine. Now, some of the name of the elements are derived from the scientists that basically discovered them. So the scientists gave them their names. There are interesting facts about the elements, but most importantly for us is knowing the symbol and the name for the elements. So the periodic table that will be given to you includes the symbol for the elements, not their actual name. So you are required to know the name and symbol of the elements. So I want you to memorize the name and symbol for the first 56 elements on the periodic table. So you can do this, little by little. Start with the first 20 and then 38 and 56. But eventually, I want you to know the name and symbol for the first 56 elements. Now, some of these elements, their symbols, you may know, but some of them, especially like some of the transition metals, may be new to you, but by practice, you learn them. Now, let's see how we write the symbol for elements. It is important to know the symbol and also name for the elements, because where we're going with this is writing the chemical formula for different compounds. When we write the chemical formulas, we just use the symbol of the elements to write their chemical formula. So it's very important that we know the symbol for each element and also know what each symbol represents. Now, the general rule for elements and their symbol is that if the symbol of the element consists of only one letter, that letter has to be in caps. And if the symbol for the element composed of two letters, the first letter is in caps, the second one is in lowercase. For example, if I say, let's say, copper. So, for example, if we write Cu, this represents copper. So the first letter is in caps, the second one is in lowercase. If I say, let's say, CO, this represents the element cobalt. Now, if I write capital C, capital O, this does not represent cobalt. This represents a compound to me. This represents carbon monoxide. So learning the simple symbols and the proper way of writing them is extremely important. So whenever you look at a symbol, even for units, pay attention and see if it's in capital letters or lowercase letters. Now, in the periodic table, each box represents an element. And as I mentioned, the symbol for the elements are either one letter or two letters. Who knows what AU represents? It's gold, yeah. So the numbers that come on top of each box, those are called the atomic number. We'll talk about the atomic number and I tell you what they represent. So in this table, I also show you some of the symbols for the elements and also their name. Again, start memorizing them. Memorizing the elements and their symbol takes a little bit of time. It can't be done all at once. So take at least 5, 10 elements, 15 elements each day and memorize their symbol and their name. So this table, the name of the elements, some of them they match their name, some of them the symbols basically don't match, and these are more of the name of the elements and their symbols. So again, as I mentioned, the first letter has to be capitalized, the second letter has to be in lowercase in order to represent the correct symbol for the elements. Now, all the elements that we know and we will be working with are in the periodic table. This periodic table was first discovered by, I believe, a Russian scientist. And what we want to show you in this chapter is that the elements in the periodic table are not placed randomly at all. They're placed based on some of their physical and chemical properties, and actually we can get lots and lots of information from the location of each element in the periodic table. Now, in order to be able to read the periodic tables, we have to have a systematic way of reading the periodic table. So two ways we can find and locate the elements in the periodic table. We can either define groups and period for the periodic table, and this way we can locate each element in the periodic table. So groups in the periodic table are basically the vertical columns. So when the vertical columns, when you go up to down on the periodic table, these are called groups. And when you go across the periodic table, this is called a period. Now, on the periodic table, in order to be able to locate the elements, we're going to number the periods and the groups. So there are two ways, two systems to number the groups. One system starts from 1, 2, 3, all the way to 18. And then in another system, we split periodic table into main group and transition metals. So you go 1A, 2A, everything in the middle is going to be B elements, and then 3A, 4A, 5A, 6A, 7A, 8A. So this A and B is going to be the system that we will use the most in this class. Now, in terms of periods, we number the periods too. That's when you go across from left to right in the periodic table. So this is going to be period 1, period 2, 3, 4, 5, 6, and 7. So lots of information we can get from group number and period number. So some of the information, we talk about it today. Some of the information, once we learn the subatomic particle and the structure of the atom, we go back and we relate it to the numbering of the periods and groups in the periodic table. So look at your periodic tables. So what's the name of the element that is in period 2? And group 5A? Nitrogen, very good. So period 2, group 5A is going to be nitrogen. Now find aluminum in the periodic table. What's the symbol for aluminum? Al, very good. It's element number 13. Find aluminum. What group is it in? 3A, very good. What period? 3. So by group number and period number, we can locate each element. Now there are some of these groups and some of the elements in the periodic table, they have a special name, and I want you to memorize the name for each one of the groups in the periodic table. Now, group 1A are called alkali metals. So all the elements in group 1A are called alkali metals. That means lithium, sodium, potassium, rubidium, cesium, and francium. So all the elements except for hydrogen. We'll talk about this because hydrogen is not a metal. All the elements in group 2A, we call them alkaline earth metals. Now, the middle section in the periodic table, those are transition metals. And then if you move across the periodic table, group 8A are called noble gases, or we call them inert gases too. And group 7A are called halogens. So you need to memorize the name of each group. The periodic tables that will be provided to you will not have this information on it. The only information on your periodic table is going to be the symbol for the elements and the numbering for the groups. There is another way that we can actually classify the elements in the periodic table, and there is another way that we can get more information from the periodic table. So we can classify all the elements in the periodic table to 3 groups. We can classify them as metals, nonmetals, and metalloids. So the metals in the periodic table are shown in blue. Non-metals are shown in green, and metalloids are shown in like a pinkish color. Now, as you see in the periodic table, most elements in the periodic table are basically metals. So why is this important for us to know what properties? Because let's say you want to make something that's a conductor. We know that metals are conductors. So if I'm looking into synthesizing a material that's going to be a conductor, I'm just going to focus on the metals. I'm not even going to look at the non-metals. Just one other thing that I want to mention here in the periodic table is these two boxes on the bottom here. These are called rare earth elements. So rare earth elements are also metals. The reason we put them down here is because their physical and chemical properties are very different from transition metals and main group metals. You won't hear much about rare earth elements in this class. When you take more advanced chemistry classes, you hear more about rare earth elements. But rare earth elements have very interesting magnetic properties, and most of the electronic devices that we use have rare earth elements in them. So we have main group metals, group 1A and 2A, except for hydrogen, those are main group metals. Also group 3A, aluminum, gallium, except for boron, those are main group metals. In the middle, you have transition metals, those are metals too. We also have the rare earth elements, and then non-metals and metalloids. Now we're going to look at the general properties of metals, non-metals, and metalloids. So metals are solid at room temperature except for mercury. So the only metal that's liquid at room temperature is mercury. The reason metals are solid at room temperature is because the forces, attraction forces in between the atoms of metals are extremely strong. Those are called metallic forces, and metallic forces are the strongest type of forces. So these metallic forces keep the metal molecules close to each other. That's why the metals appear to be solid. Metals are usually shiny. If they're oxidized, they may not appear shiny, but metals are shiny. In the research lab, one of the ways that you can tell if your compound has metals in it or not, you look at it. And if it's shiny, you call that a metallic shine. You know that there is a metal in your compound. Metals are good conductors of electricity and heat. They're ductile and they're malleable. Now let's look at the general properties of nonmetals. So one other physical properties of metals, they have very high melting points, and the densities are very high too. When we get to chemical equations, I show you the properties of the metals and how they react with oxygen and other type of elements or nonmetals. So one of the important compounds that we will learn in this class are ionic compounds. which are binary composed of only two elements, one metal, one non-metal, and they actually form salts. That's one of the importance of metals. We're going to learn how to write the chemical formulas for the salts and how to name them. Now let's look at the general properties of nonmetals. So these properties that I show you for the metals and nonmetals, these are physical properties, meaning that, these are the things that we can use to easily tell if something is a metal or a nonmetal. So nonmetals are not shiny. The reason metals appear shiny and nonmetals, they're not shiny, is because of the electrons. So once we get to the structure of the atom, we talk about valence electrons and how valence electrons are mobile. So we're going to learn that the reason metals are shiny is because the valence electrons basically transfer and move across the structure of the metal, whereas for nonmetals, that doesn't happen. So nonmetals, they have low melting point and densities, and they are poor conductors of heat and electricity. Nonmetals, they can be found in the form of liquid or sometimes even gas, and sometimes in the form of a solid. So the forces or interactions in between the molecules of nonmetals is not as strong as metals. That's why they can be found in a liquid, gas, or solid state. Now, when nonmetals, two or more nonmetals are combined with each other, they form molecular compounds. We will look at these molecular compounds, how to write their chemical formula, and also we look at the naming of the molecular compounds. Now, the last group are the metalloids in the periodic table. Metalloids have properties in between the metals and nonmetals. Their properties is not 100% like metals, and it's not 100% like nonmetals, something in between. For example, metalloids are semiconductors. And some of these metalloids are actually cheap semiconductors, so they're used a lot for electronic devices. Now, why is this important, again, to know the properties of metals, nonmetals, and metalloids? Let's say I want to make a compound. Let's say you want to make tables for your classroom. Where do I start? Do I want to use a metal or non-metal for these tables? There are a few things that we got to think about. We want it to be a sturdy. Sturdy means metal. But if you use a metal, the tables are going to be extremely heavy, right? We learned that metals, the density of metals are very high. So if they're too heavy, we won't be able to move them. Also, we know that metals are conductor of heat and electricity. Is that practical? Do we want like iron tables in the room? They get super cold, super hot, they're heavy. So maybe just metals is not the answer. On the other hand, you want non-metals, so it's not a conductor of heat and electricity. You want it to be lighter. So at the end, maybe we need to have a combination of metals and non-metals to make the material that we want to. For example, if you're looking into making an insulator, we know that we shouldn't go after metals at all. Any compound that we make as an insulator has to be a non-metal. Otherwise, it's not going to be an insulator. So these general properties of metals, nonmetals, and metalloids give us the first direction on how to choose what elements. But obviously, there is many options for metals, nonmetals, and metalloids. And then once you decide if you want a metal or non-metal or a metalloid, then you narrow down your search to see exactly what element you want to use for the material. Based on the properties that you're after, you choose what type of element to use. So let's do a couple of practice problems. What's the symbol for silver? So let's look at the symbols and the name for each one of these. What does S stand for? It's sulfur. Si, silicon. Ag, silver. Au, this, strontium. Very good. So make sure that you memorize the name and symbol for all the elements. Now let's do another example. Which of the following elements are metals? In order to answer this question, you have to look at the periodic table. So look at the periodic table. Based on the location, you can tell if something is metal or non-metal. So let's find sodium in the periodic table. Is sodium a metal or non-metal? Metal. Very good. Now, what group does sodium belong to? What's the group number? Group number is 1A. Very good. Do you remember the name of group 1A elements? Alkali metals. Very good. Now let's look at molybdenum. Mo is for molybdenum. Molybdenum is element 42. Did you all find molybdenum? Yes. Is molybdenum a metal or a non-metal? It's a metal. What type of metal is it? Transition metal. Very good. Chlorine. Find chlorine in the periodic table. It's element number 17. Did you all find chlorine? Now, is chlorine a metal or a non-metal? It's a non-metal, right? Now, what's the group number for chlorine? It's in group 7A. What period does chlorine belong to? Period 3. Very good. What's the name of the group 7A elements? Halogens. Very good. Now, let's look at magnesium. Magnesium is element number 12. Did you all find it? Is magnesium a metal or a non-metal? It's a metal. Very good. What type of metal is magnesium? Alkaline earth metal, and it's one of the main group metals. Very good. PT stands for platinum. Platinum is element 78. Is platinum metal or non-metal or metalloid? It's a metal. Very good. What type of metal? Transition metal. Very good. Krypton is element number 36. Is krypton metal, non-metal, or a metalloid? What is krypton? Non-metal. Very good. What's the group number for krypton? 8A. What are the elements in group 8A called? Noble gases or inert gases. The reason we call them noble gases or inert gases is because they're actually inert. They don't participate in any sort of chemical reaction. It's impossible to get them to participate in any sort of chemical reaction. I stands for iodine. Iodine is element 53. Did you all find iodine? Is iodine metal, non-metal, or metalloid? Non-metal. What's the name of group 7A elements? Halogen. So iodine is a halogen. Now, what does C stand for? That's carbon, right? So carbon is element number 6. Group 4A. Now, is carbon metal, non-metal, or metalloid? Carbon is a metal, non-metal, or metalloid? Carbon is a non-metal. Very good. Now, Cu stands for copper. Copper is element 29. Did you all find copper? Now, is copper metal or non-metal or metalloid? It's a metal. What type of metal is copper? Transition metal. Very good. So one other fact about the elements, and we will talk about it more later on. Group 1A and 2A metals, alkali and alkaline earth metals, are extremely reactive, whereas the rest of the metals are not as reactive of group 1A and 2A. When I say reactive, meaning that we can't let them, outside. They react with the oxygen, they react with the air, and their reactions are actually very explosive. So we always keep them in a way that they're not exposed to the air, because if they're exposed, they react with the oxygen in the air, and we get combustion reactions, and they react with the water too. So they're explosive. Whereas the rest of the metals, transition metals, rare earth elements, are not as reactive, but they can still react with the oxygen in the air. So let's talk about compounds a little bit. The elements in the periodic table, in their elemental form, they serve as metals, nonmetals, metalloids, and they have some properties. But in reality, if you have only one type of metal or one type of nonmetal, it's not all that practical. What we want to do as chemists is basically combining these elements to make compounds. We barely find elements in their elemental form in nature. Everything is a combination of different elements. So we want to see how elements basically react with each other, and elements just know that they have the tendency to react with each other. There are exceptions. For example, inert gases, noble gases, we just said that those are unreactive. They don't react with anything else. But for the rest of the elements on the periodic table, there is a way that we can actually get them to react with each other, and they form compounds. Now, the compounds they form, it can be consist of 2 or more elements. And usually when they combine with each other to form compounds, they achieve more stability through, that combination and formation of a bond. Energetically, they become more favorable. That's why they have the tendency, elements have the tendency to react with each other. Now, there are some elements and metals that basically are not all that reactive. It doesn't mean that we can't do any reactions with them, but in nature they're not all that reactive, and they tend to stay as elements. For example, gold, silver, and platinum. These are some of the most unreactive metals. Now, since they're unreactive meaning that, let's say in nature, on Earth, in the soil, they don't react with the oxygen in the air. If metals react with the oxygen in the air or humidity, they form metal oxides. That's corrosion, so that's not favorable. But these metals, gold, silver, and platinum, those are the most unreactive metals. That's why we make jewelry out of these metals, because when they're exposed to the air, they don't rust, they don't react with the oxygen in the air. And that's why these elements are very, very expensive too. So first of all, they're metals, they're sturdy, but since they're unreactive, that's one of the reasons that they're extremely expensive too, and we use them for jewelry. And since they don't combine with anything else, finding them is also a challenge. Now, an example of a mixture of elements is air. Air is composed of mainly composed of nitrogen and oxygen. Air is a homogeneous mixture of different gases. So just to show you what gases we find in the air that we breathe, there are traces of other gases in the air. But one thing to know about some of the gases, we're talking about natural state of the elements. So some of the gases are found in diatomic form. Diatomic meaning that as an elemental form, they're found as two atoms. Those diatomic molecules are these ones, and you need to memorize these diatomic molecules. So what this means is that, for example, hydrogen gas never exists. So if I say hydrogen gas, it never exists as hydrogen. There is no such a thing as H for hydrogen gas. It's always H2. There is no such a thing as just O. When I say no such a thing, it doesn't exist, meaning that it's not stable. These gases, these molecules are only as stable as diatomic molecules. So it's always O2. It's always F2Cl2Br2I2. So this becomes very important when we start writing chemical equations. So when you write equations, you gotta remember that these particular ones are diatomic and not monatomic. Di means 2. Mono means 1. So most of the elements, actually the rest of the elements on the periodic table in elemental form, they are monatomic, maybe means only one atom. But these hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, those are diatomic, composed of two atoms.